In 7.4b, we're really just going to be focusing on graphing our sine and our cosine functions. So what we've done is we started talking about how to solve sine and cosine functions using special right triangles. So we're going to bring that into what the graphs of a sine and cosine function look like, and hopefully this will kind of come together and you'll kind of see what we've been doing and what we've kind of been accomplishing. So this should be a pretty quick video. So we're going to do the graph of sine first, and what you're going to notice that I do is I'm going to label the graph first. I'm going to say this is going to be a positive one up here, and then this is going to be a negative one. And then while we do the sine function, what I'm going to do is I'm going to label my x-axis just so you can get an idea of how this is going to work. I'm going to first label it with degrees. So I'm going to say that this first line right here is 90 degrees. Then I'm going to say this is 180 degrees, then 270, and then 360. And now what I want you to think about is we've kind of already gone through this, but when we talk about the graph of a sine function, you know, obviously we start with 0 degrees right here. So we've talked about what our function's equal to. So if I wanted to know what the sine of 0 degrees is, you think about your little unit circle here, and then we talk about where we start and what the value of the sine function is there, and then we get to the 90 degrees and we talked about what the value was there, and we talked about what the value was there. So at all these lines we know what the value is because we know the sine is our y value. So our y value here is 0, so therefore when I graph my sine function, I know that my first value is going to be at 0. So that's where I start. Now, when we go to 90 degrees, it shifts up to 1. So then it goes up to 1. And then we go back down to, at 180 degrees, it's back to 0. And then at 270 degrees, it's going to be at negative 1. And then at 360 degrees, it's going to be back to 0. So what's going to happen is this is called the sine curve. And it's not going to be a jagged line. It's going to be a smooth curve that looks like this. Now, what you should understand is that we talk about how, remember we've said over and over again that this can keep going around and around and around and around and around and around over and over again. It's a cyclical function. So once we have, what we've done is we've gone from 0 to 360. Now we're going to learn this in the future, but what this is constituted is one full period of our sine function. We started at 0 and came all the way back around to 360. Remember, 0 and 360 are in the exact same spot. So this is just going to continue on, and you could keep this going on forever. You can get an idea of what it's going to look like, and then we can even continue it here. And it's a perfectly cyclical function. And it will just look like that over and over again. Now, this is graphed really easy because it's in degrees and we have our x-axis in degrees. What your assignment is going to be is being able to graph a sine and a cosine function just using regular numbers like 1, 2, 3, and 4, which still isn't that difficult. We just have to convert things into decimals to know, where they're going to be at, like where is 90 degrees at. So let's talk about what our first step in doing that would be by doing a cosine graph. So cosine graph, what I want to do is, I'm not going to use degrees to label this. What I want to use is I want to use radians now to label this. So that's going to still be 1 and that'll still be negative 1. But now instead of it being 90 degrees, we're going to say pi over 2. And then we're going to say pi. And then we're going to say 3 pi over 2. And then we're going to say 2 pi. And then on the other side, we could say negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. And again, we're using the same idea. Cosine is our is our x value. So our x value here is 1. So instead, our cosine is going to start up here at 1 when we're at 0. And then at pi halves, it's 0. And then at pi, it's negative 1. And then at 3 pi, it's 0 again. And then all the way back to 1 once we get to 2 pi. And once again, we can draw a smooth curve here. which this is one full cycle of our cosine function, and then we can certainly continue it on from there. So I could continue it down through the 0, down to -1. Not the easiest thing to do to draw these graphs using a Mobi like this, but you guys get the basic idea. It's not jagged, it's a smooth curve. And what you should notice here is that our cosine function is shifted exactly 90 degrees to the left of what our sine function is. You could even say that it's, there's a lot of ways that you can shift it because it's a cyclical function, but you can see it's the exact same curve, it's just shifted a little bit. The cosine function here starts at 1, the sine function starts at 0. So we just need to get comfortable with what these graphs look like and how to graph them. And like I said, on your assignment, it's going to be real basic and real straightforward for this portion. Is I'm going to want you to graph a sine and a cosine function, but instead of using 90 degrees, 180, 270, and 320, and then pi halves pi, I'm going to want you to use 1, 2, 3, 4 in radians. So hopefully this makes sense. This is an introduction to what a graph of sine and cosine looks like. Kind of gives you the idea about how it works in a cyclical fashion on a coordinate plane. So I will see you in class. Bring questions then.